Hi, so my name is Ethan, and this is my first video. And the goal I kind of had with this TikTok page is just to kind of, I don't know, like introduce higher level math concepts to people, because I feel like a lot of people want to learn higher level math concepts, but they're just like kind of intimidated and don't really know where to start. And so if you're interested in learning math, you should watch this video. So today, the kind of idea I had was just to go over some of like the notation and like shorthand you'll see in a lot of higher level math classes like discrete math or analysis, or anything like that. Because I don't know, it can make what you're learning super convoluted, but like the actual statement is like trivial. And so it'll just make math a lot easier to understand if you understand the notation behind it. And so with that said, let's start. So this right here, this backwards E, it just means, in English, it means there exists. So if you have like, you can say like there exists like an x greater than 4, then you know that like you have an x greater than 4. So in English, this just means there exists. With it crossed out, this next one, this just means there does not exist. So if you don't have something that exists, you just say there doesn't exist. So actually we can write out examples. We can say like, I don't know, like there exists an x greater than 4 here. There does not exist an x less than 2. I don't know, it's just random statements. There exists or does not exist. You can use it however you want. That's what it means. For this next one, this little epsilon here, this means is an element of. So if you have like an object and it's an element of something else, if it's an element of a set, if it's in something else, then you would use this little symbol and say it's an element of. So if we have two sets, these little brackets mean sets. Actually, we'll say 1 is an element of the set 1, 2, 3. So 1 is in this set, and this next one, the negation, this means not an element of. So we can say like 4 is not an element of this same set 1, 2, 3. Okay? So this is a set, this is just a collection of objects, and these are just integers, numbers, and that's what these two mean. Is an element of, is not an element of, okay? This little upside down triangle, or upside down A actually, this means for all. So if you want to make like a large generalization, say for all something, I don't know, we can say like for all natural numbers, something happens. Yeah, that just means, I'll write it out, for all. This is shorthand for therefore, so I think you can see it. Yeah, these little 3 dots here, this means therefore. So if you want to say like instead of like because, you can just write these 3 dots and it means therefore. Okay, sorry, my handwriting's so bad on the blackboard, but you'll have to deal with it. These little 2 crossed lines with 4 dots, this means a contradiction. So if you're doing like a proof by contradiction, you reach your contradiction, you can draw this little symbol, and it just means that you have a contradiction. So if we say like 2 equals 4, we can write this little contradiction thing behind it, because this is a contradiction, this is not true. So yeah, it's an example. Now this is more for like sets here. I mean, it's more general, but the union of something is just like them combined pretty much. So if you have the union of 2 sets, let's say like 1, 2 union 3, 3, 2, this is just going to be 1, 2, 3. Right, because the elements in sets are unique, so since 2 is in both, it only appears once. I mean, yeah, okay. You can also think of it, I don't know why I use this example, I should use a Venn diagram, but if you think of it as like a Venn diagram, the union is just everything in both. So it's just the entire picture. So if this is A and this is B, it's going to be everything in both. The intersection is just what's in the middle. So if you have 2 Venn diagrams, it's just going to be the overlap here. This is the union. That's what that means. And sorry if I'm moving a little fast, but yeah. This next little arrow, this means like implies. So if something implies something else, 2 statements, we can say like P, statement P implies statement Q. And we can say P is like it's raining outside. It's not actually raining outside, but if it was, let's say it's raining outside, and then we can say Q is like, if I go outside, I'll get wet. So like, it's raining outside, I'll get wet. So like, since it's raining outside, it implies that I'll get wet if I go outside. So that means implies, and then equivalence just means that both two statements are equivalent to each other. So this one is that this statement, if this statement is true, then that implies that this statement is true, okay? But equivalence means that this one is true if and only if this statement is also true. So if this one's false, this one has to be false. But if this one's true, this one has to be true. And same for vice versa. So yeah, so like P is equivalent to Q. What's two equivalent statements? I don't know, like 2 equals 4 and 4 equals 2. Those are equivalent. So that's an example there. Okay, moving on. This is more like Boolean logic, but we have this little symbol here. This like, I don't know, is it like a caret? Do people call it a caret? I don't think so. It looks like a crowbar. So it's like it's a little line with it's like a crowbar. This means not. So it's similar to like the cross, when we crossed out there exists. It just means not. So whatever A is, it's the opposite of A. So if A is true, not A is going to be false. And if A is false, then not A is going to be true. This means for two like Booleans, like true and false variables, this means and. So A and B, I don't know if you guys can see, I made a little truth table over there. So A and B, so and A and B is only going to be true if A and B are both true. So it's true because A and B are both true, but if one of them is false, it's going to be false. So it's true, false, false, false here. And then A or B, this equates to true if A or B is true. So it's going to be true, 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 because at least one of them is true, and then on the last one, when they're both false, it's going to be false. And then the last thing we have here, this denotes a subset. So let's say we have the set 1, 2, the like integer 1 and 2, and then we have the set 1, 2, 3. You can say 1, 2 is a subset of the set 1, 2, 3 because every element of set A is an element of set B. So using the notation we wrote over there, for all x in A, x is also in B, okay? And then this, so with the little line under it, this just means a subset, but this means a proper subset. So I think I got that right. I hope I got that right. I don't know. I always get confused. But a proper subset is just where it's not the set itself and it's not the empty set. So if you have a set like the set 1, 2, it's weird, but 1, 2 is actually a subset of the set 1, 2. So any set, the set itself is also a subset, if that makes sense. So 1, 2 is a subset of the set 1, 2, and the empty set is also a subset of the set 1, 2. So a proper subset is not the empty set, and it's also not the set itself. Actually, okay, wait, I could be wrong. The empty set could be a proper subset. I think a proper subset just has to have, it just can't have all the elements of the like set that it's a subset of. So as long as you have at least one element that's not in, so if you have A as a proper subset of B, there has to exist an X in A such that X is not in B. That's how we would write that using that notation. So this just reads, there exists an X in A, so we have an element in A, such that X is not in B. So it's in A, but not in B, okay? That's a proper subset. So yeah, that's everything I have. I hope this was helpful. If you stayed this far, leave a comment. Maybe like suggest what you want to see me go over next, and I hope this was helpful. So thank you.